Yes, streaming is going on. So coming back to ECEDA user interface. Yeah. So first I will again show you how to place a text. Click on place option. So click on text. Click on text. And here you can type whatever you want to place. Let's say I want to type LFR, line following robot, LFR. Okay. And then here you can change the color of the font color, and you can, there are multiple font families you can change, but default is Arial and default font size is 0.08 inch. If you want to increase the font size, you can increase it. And here there is the formatting option, bold, underline, italic. So these things are there. Now if you just press enter button, directly this line will be placed. But if you want to break the line, let's say if you want to break the line, add a new line, you need to press shift plus enter, or else control plus enter, or else alt plus enter. There are three options. It is mentioned over here also. Shift or control or shift or alt plus enter. Or else if you directly place an enter, it will show you, it will, uh, you will be redirect to placing the text. Now if you, after placing the text also, you can modify it, the properties. Okay, like let's say you felt that the text size is very small and you want to increase the text size. Okay, so to
Yeah.
do that, just click on the text. So on the right side there is a property option. You can see that, right? Property. You are able to see that property,
Oh
right side.
yes.
Yeah, click on that property. Here you can increase the size. Let's say now I want 0.5. It's very big. I will go with 0.35. Yeah. So this is how to place a text in a schematic design. Okay. Now I will show
Oh,
you one pre-existing project. I'm going to file. So this is the basic. Okay. Now I'm going to pre-existing project to explain you the schematic. I'm going to click on open project. I'm going with a pre-existing project for demonstration. That is BMP 280. So in the BMP 280, so I'm clicking on schematics. So this is the schematic diagram of BMP 280. You can see the circuit diagram, right? Let me
yeah.
collapse the property tab. So this is the circuit diagram. So now, do you think is there any importance of teaching you how to draw? Earlier session, I told you how to draw arcs just a few minutes ago. Different curves. So can you just tell me a couple of areas where we have used those options that I explained a couple of minutes ago?
For above cube set, you have used.
See, here we have placed a rectangle. You can see that for heading. This is
Yeah.
a rectangle. This rectangle is drawn with the help of, we went to place and we have clicked on rectangle option. We have drawn that rectangle. And here we have placed text. This text is also placed with the help of going to place option, text. But we have changed it. We have increased it some text size, chosen some other font family, and bold. There is a formatting option. If you click on that, if you click property option, here is the bold option, right? Bold. If you want italic, you can do that, underline. So those kind of thing. So we have chosen Arial bold font family. By default, it's Arial. We have chosen Arial bold. So now you might have wondered how we have placed these images, right?
Yes.
So there is a place option. In the place option, there is the just below the text option. Okay, earlier we have placed the text, right? Just below the text option, there is image option. See, I'm just magnifying my screen. The image option. So once you click on that image option, it will take you to the file manager. So it will ask you to select an image. I'm going to select this image. I'm pressing enter. The image came, isn't it? So yeah, now I need to decrease. Just click on this image. Just how you edit an image in a Word document. Similarly, you can reduce the size of the image, or else you can go to the properties section. You can modify the width and height also. So this is how we place the images, multiple images. Okay, you understood now how to place an image, how to place text. how to draw a curve rectangle. Yeah, is that fine? Hello.
Yes, yes.
Yeah, I hope you understood up to here, right?
Yeah.
So now pay attention. I will be explaining you the schematics, which we discussed in the lab session. This is the important aspect. Till now we discussed the theoretical thing, all this stuff. Now we'll be discussing the hidden science behind the few things. So whenever we place some component in a schematic, behind that there will be always some science existing behind that. There will be always some purpose serving behind that. Okay. So
Okay.
now here we one more thing. See, this is the you might wonder. So this is actually how we placed this dotted dashed thing. Okay. This should be explained while we are explaining the uh, those curves while I'm explaining the rectangle, but I forgotten that. I will like, tell you now. So just give me a second. So this is how a rectangle would look like, right? Isn't it? This is how a rectangle would look like. Am I right?
Yes.
Yeah. So how we place this rectangle, you remember? How we
Yes.
placed it? Yeah. Can you just tell me first we need to click on which option?
Place.
Place option. And after clicking place option, you need to click on rectangle. That's how
Correct.
you have drawn this rectangle. So does this rectangle carry any electrical significance or what's the purpose of adding the rectangle over there?
Just for human interference.
Yeah, just here we have added one label, right? That SD0 pin must be grounded to lock the I2 address at 0 into 76. So just to, it's like a documentation. Okay, do not carry any significance. But these wires you can find over here, these are actual wirings, connections. They carry electrical significance. This is just for human understanding. So you can, once you, if you, for documentation, usually we place a rectangle and there is multiple line styles. Click on line style. There are multiple options like solid, dashed, dotted, dotted, dashed. Usually we use dotted dashed for documentation purpose. Okay. So now you do one thing. So you just start sharing your screen. Okay. Can you just share your screen?
I am from mobile.
You are joining from mobile.
Yes,
Okay.
but in
Okay. Okay.
front I can open laptop.
You have laptop with you readily available.
Yes,
So do
I have
one.
opened TGETS.
Okay. So can you just join the same meet from your laptop as well right now? Because now I just want to make few things with the like you need to do few things. I will teach you.
Okay.
LCSC library, how to add components, those kind of stuff.
Okay.
Yeah. So you can just join the same meet, meet.suchana.in. I will stop sharing my screen. Now you need to share your screen. So after this, there's a quiz. Have you ever participated in a quiz last time?
Uh, yes.
You're already participated in quiz.
Yeah.
Oh, okay.
Quiz means in which type of?
Like in Kahoot website.
No.
Okay, our quiz. I'm not talking about other quizzes. We are also we have conducted one quiz. Interesting quiz.
No.
Yeah, okay, okay. So after this thing, uh, we'll be having a small quiz. It's like a game. We have a Mihir also in the group in the session. So it's like competition between you both guys who will gain good marks. Uh, as of now, we have covered up to here. Questions, small questions will be asked from them among these concepts. Now click on
Okay.
Pro Edition.
Now what I have to do?
Are you sharing the entire screen? Just go back to Google Meet
Oh,
and stop sharing the screen. Just click on entire screen. Maybe
okay.
you are sharing a specific window.
Yeah,
Just go back to Google Meet, stop share and reshare with selecting entire screen.
I have made a new product. Uh,
Yeah. So now in this project, now if you want to place some component, first you let's say let's go with the basic components. How to place a resistor? Okay.
okay.
So first, any PCB require power supply to operate or not,
Yes.
right? So that means we need something called VCC and something called ground. Okay.
Yeah.
So now click on, there's a VCC option you can see. Yeah, click on VCC. So first option VCC. So VCC means positive power supply. Just click on that. Yeah. So that means it's a positive power supply. So can just zoom in the screen.
Yes. Yeah.
Use your. Are you using an external mouse or onboard mouse?
No, on board.
Onboard. So you need to use two fingers to do that.
Yes.
Okay. It
One
would be.
minute.
It might be a little bit difficult initially to operate.
Yes.
As you are using, you will get a commanding over that. Yeah. Now you can place the component over there. Have you placed that?
Yes. Now.
Now click on escape. Yeah. Now again, click on the same VCC drop down. So click on ground. So just like a battery have two terminals, positive and negative. This is something like that, equivalent one.
Yes.
Okay. Now, if you want to place some resistor, there's a resistor option over there. Can you just identify that? Yeah.
Uh,
Just right one. Yeah. Click on that. Yeah. That's the resistor. See, automatically designator came.
yes.
Now you place one more resistor, automatically the value will be incremented to R1. Instead of R1, you will get R2 next one. Yeah, you can place yeah,
Yeah.
right? Yeah. Place that second one and click on escape. Now add a capacitor. I will tell you how to add a capacitor. So just on the same resistor option, there's a drop down.
Yes.
Click on capacitor. Similarly, you can add a inductor and diode as well. So now
Okay.
can you just tell me, is it a polarized capacitor or non-polarized capacitor?
It is a non-polarized capacitor.
Because there is no positive symbol indicated on one terminal, right?
Yes.
Now the first resistor, what's the value of the first resistor? Can you just tell me?
10K.
10K. That means 10 kilo ohm. Now we want to change the value. Let's say 1 kilo ohm. How can we modify that?
Like
See, I'll tell you. Just click on the resistor. First click on the resistor. Okay. Now property section. Go in the property section. There will be value.
yes.
Can you scroll down? No, not that one. In the bottom, under the key properties. In middle, exactly at the middle, you can find right value, which
Yeah.
is it. Yeah. There you need to modify. Just change it to 1K. Press enter. That's it. How this is the procedure. How to change the or assign a value to a resistor. Now I have already told you that should the designator of a resistor should always begin with R only. Is it a strict enforcement or is it just a nomenclature?
Nomenclature.
Now let's say if you want instead of R1, you want to type res1. Res means resistor, let's say. So you can change the designator over there. Yeah, I can
Yes.
change it. Yeah, that's how you need to do that. But by default, it should be R. Now again, change it to R back again. Standard one, R1. Yeah. So always make sure that no component is having same designator. Okay. This is the first point that you need to understand. Make sure that each and every component is having unique designator. Is that clear?
Yes.
Yeah. So now this is how you need to add a resistor and capacitor. But you have added a capacitor, that's fine. But how many do you think? How many types of capacitors are there actually?
Uh,
Not based on
maybe
polarity, maybe some based on model or type. There are many,
too many.
too many. So you know about through hole components and SMD components?
No.
Don't know? Okay. Open a new tab. Just search for a through hole capacitor. Through hole capacitor. Through hole capacitor.
Two
Or
hole.
else through hole. THROUGH space HYLE hole. Or else search for through hole resistor first. Resistor. So go to images section. So this is through hole resistor. So why it is
Okay.
called through hole?
Because it can pass through the hole in the
Holes. So
PCB.
on the PCB you will have holes. From that holes, copper traces would emerge. So that's why this is called through hole. Now on the new tab, search for SMD resistor. SMD. So SMD means a surface mounted device. Surface
Oh,
mounted device. Search for SMD.
okay.
Okay. Now just open some image. Maybe can you scroll down? Scroll
Okay.
down. Where I need not on just component. I want component to be present along with the PCB. Yeah, that one.
Yeah.
No, no, this side. Yeah, that one. See, those all those devices are surface mounted. Okay.
Yes.
Now you understood. So
Yeah.
capacitors are so many types. Aluminum capacitors, tantalum capacitors, so many different kinds of capacitors are there. Film capacitors. So now, how can you choose the correct capacitor? Adding a symbol, is that fine? Not necessarily, right? We need to choose the correct component. There are multiple variants are there, isn't it?
Yes.
So for that, I'm telling you how to select a component. Selection of a component. The topic is selection of component. So on the new tab, just visit a website. You can close those SMD and through hole tabs, and instead open a new tab. Just type LCSC. LCSC. Yeah, press enter. The first website. So here, whatever may be the component could be. It's like a huge database, complete database of all components. Okay, every component will be available here. From this website, you need to choose the component. How will you be choosing that? Let's say you
Like
want an aluminum capacitor. So on the search bar, type for aluminum capacitor. Aluminum capacitor. Yeah, press enter. Just scroll down. Sometimes for few components, images may not be available. Sometimes it may take a little bit time to render the images. Okay, just wait for a few seconds. Can just try to move your cursor over that image, small image, tiny. Maybe
no.
it is not yet loaded, I think so. Okay, or else you do one thing, just simply search for capacitor. Just directly search for capacitor. Scroll. I think capacitor spelling is wrong, so that's why it is not showing capacitor. CITIOR, capacitor.
Oh, CI.
Yeah, capacitor. Yeah. Now search. Yeah, see, these are different categories. Now, on the first row, first column. I mean, second one. Second row, first column. Come to the first column. Yeah, second one. Aluminum electrolytic capacitor. Yeah, click on that. That is how aluminum capacitors look like. These are widely used. So you have used Arduino Uno, right?
Yeah.
Now can just open new tab and search for Arduino Uno and go to the images section. Can just try to identify what kind of capacitor is there on the PCB on Arduino Uno. Yeah, go to images. So yeah, any one of the image. So no, already you have a magnification tool. Just try to click on the spot where the capacitors are there.
Like these.
see, just behind the barrel jack, power supply port, you know the
Oh,
power supply, that's the USB. Yeah, those are the
USB.
capacitors. Try to click on that spot. Yeah, click on that spot. Okay, zoom in. So what do you think those capacitors, what kind of capacitors do you think are they?
These are aluminium assemblies.
Aluminum electrolyte capacitors. So this is how you need to choose a component. Okay, they are widely used.
Okay.
So every capacitor, certain capacitors can work within, each and every capacitor is rated for some voltage. Okay,
Okay.
depending upon the, let's say you are working at 12 volt, so you will be choosing a capacitor which is a little bit slightly higher than that voltage. Okay, so you need to choose a capacitor based on the voltage requirements. And the first important thing is the capacitance. How much capacitance you require. Okay,
Okay.
so now come back to LCSC website, LCSC tab. So scroll down, still try scrolling little bit down until you find a proper image.
If well,
See, these are all different capacitors. See,
yeah.
or else you can do one thing. You can just open new tab. There you can simply open new tab. There you can simply type. Let's say you want aluminium electrolyte capacitor. Aluminium. Just simply type aluminium capacitor and give some space. Type LCSC aluminium capacitor. Give some space. Aluminium space capacitor. CAPA CIT bar capacitor. Give some space LCSC. Yeah. And then let's say if you want a particular thing, let's say 10 nanofarad or something like that, you can mention there, or else you can simply press enter. Yeah, go with the maybe the first option. See, you can take help of Gemini also. You can take help of AI. You can give it a prompt that I need aluminum electrolyte capacitors having the value 10 nanofarad or 100 nanofarad. So it will give you the links also to the direct products. Okay.
This
Yeah.
one.
Yeah, you got one product. Let's say click on first. You just click on that link, like which is just towards the right side. Yeah. So once you click on that, you will find from this data. You just escape that. Click on done. So from the data provided, click on done. From the data provided, what is the capacitance of that capacitor?
Oh,
It is very clearly written
35
over
volt.
there. That is
100
the
UF.
that
100
is
UF.
100 UF. So that's actually microfarad. So since there's no symbol for micro, we usually use U. Okay, that's
Okay.
the 100 microfarad. So that's capacity is 100 microfarad, and it is rated for which voltage?
35 volt.
Yeah, is it a through hole component or SMD component?
SMD component.
Now you want to place this component in schematics. How will you be placing that?
Mm,
Both are different websites, right? How to place this component in that ECEDA. So there are two ways. The first one is with the help of manufacturer part name. Okay, what's the first one?
uh, R ROQANG.
Yeah, just tell the name, like no, not the exact name. I'm just telling the first thing is manufacturer part name. Just repeat with me, manufacturer part name.
Manufacturer partner.
Yeah, second one is part number.
Part number.
First one is part name, second one is part number. Okay, so these are two different ways to place a component in LCS. I mean in ECEDA from LCSC library. Basically, these LCS and ECEDA have collaborated with each other. You can place these components from this LCSC library inside the ECEDA. I will tell you how to do that. Go back to the schematics page. Okay, now we need to place the same component. Okay, here in this schematic. To do that, click on place option again. Place option. We have used the same option to place images, text, draw arcs. Click on the very first option, the very starting. Yeah,
Device.
yeah,
Use.
right. Device or use block. So can you just see that there are three different libraries available? What's the first library?
LCSC.
LCSC electronic library. Second one is,
Easy EDA.
the third one is reuse block. So this window is called as library manager. Okay, this window is called as library manager. So now we are make sure that if you want to place a component from LCSC library inside into the schematic section, you must be within the LCSC library, not ECEDA library. Okay.
Okay.
Now you are in. Can you just confirm me whether you are in ECEDA or LCSC, which is selected?
LCSC.
LCSC. Yeah. So now go back to the same page, LCSC. So copy the manufacturer part number, LCSC part number,
This
something
one.
C7, no, part number,
Yeah.
LCSC part. Yeah, copy that, go back to the same schematic portal. So now on the search field, now you paste it, Control V. Yeah. So just wait for a few seconds. The first comment, is it the same or different?
Same.
Yeah. So click on place. You have a place option, right? Yeah, you got it. Now can you just tell me, is this a polarized capacitor or non-polarized?
Polarized.
Yeah. So now you understood how to place a component.
Yeah.
Is that clear?
Yeah.
So now, if I ask you to place a BMP280 IC, how will you be placing that?
Uh,
BMP280 IC.
First, I will be searching BMP280 IC.
Yeah. You can simply search BMP280. No need of IC. Yeah. The first one already you have got over there.
Yeah.
So click on that BMP280. Copy the part number. Or else you can copy the part name, which is something Bosch BMP280 written over there, right? Above the big title in bold and letter. You can use that, or else simply the easiest thing. Make sure that you are always using part number, which is very convenient method. Simply copy
Oh,
the part number again and go back to schematic section. So now can you just try to clear, other than VCC and ground, can just try to clear out the rest all other components. You can keep the resistors, and you can keep those one resistor. You just keep one resistor, and remaining two sorry, wait a second. Can press Control Z, undo. Yeah, remove one capacitor, only one capacitor. Yeah, now you place that. Yeah, remove that capacitor. Yeah, one capacitor is enough. Now click on place section. Now I just don't know. I won't tell you. You need to place that IC into this schematic.
okay. May I place the capacitor?
No, 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 not required. Only place the IC, BMP280 IC. Okay. Now you understood how to place a component, right?
Yes.
Yeah. So now, have you ever used BMP280 module ever before?
No.
At least you might have used a few sensors. Can you just name such sensor? Maybe
Uh,
while
IR,
using Arduino module.
IR sensor, QTR sensor, QRE sensor.
Okay. So can you just open new tab and search for BMP280? Go to images section. So now you just need to tell me, uh, this BMP280 is used for which purpose?
For sensing atomic pressure, and from that we can measure the altitude also.
Yeah. So this BMP280 is used for determining the atmospheric pressure, barometric pressure. Okay.
Yeah.
And from that we can also determine the humidity, and we can determine the altitude as well. Okay.
Okay.
So you know about I square C communication or SPI, how to connect a sensor to Arduino module. You know about that.
Yeah.
You know about serial clock, SCL and SDA lines for sensors.
No.
It's actually basic thing. Whenever you use any sensor, we use some I square C or SPI. Have you heard those terms, I square C, I2C or SPI?
No, I only use analog pins and
Yeah, those
grounding
actually
this.
you have used the analog pins, but you don't know the theory behind that. So you just only, maybe you might have asked some AI how to connect the sensor with Arduino Uno. It might have given some a table. This wire should be connected to this analog pin. This wire is to connect it, right? Like that, right?
No, my sir taught me that.
Oh, okay, fine. So there is something called I2C protocol and SPI protocol. So I request you. So after the completion, like already one more course is there, called Embedded C and ESP32 course. We request you kindly please also enroll into that. You will definitely learn something new knowledge. Okay, we will be explaining the I2C protocol, SPI protocol. So there is something like every sensor is able to send some data to the microcontroller. Am I correct or not?
Yeah.
So this is called as master slave relationship. Okay.
Okay.
So here, What is compared with master and what is compared with slave?
Master is compared with the sensor and slave is compared with the microcontroller.
It's exactly opposite to the actual reality. So master is the microcontroller, slaves are sensors. So master is controlling the slaves. So you are connecting a Arduino Uno with sensor, or you are connecting sensor to Arduino Uno.
Mm. I am connecting each other with
Yeah, we are connecting eternally. We are connecting each other, but whenever we are referencing
oh
to it,
sensor to
how will
Arduino.
you say that? Yeah, I'm
Sensor
connecting a
to Arduino.
sensor to Arduino Uno. No one usually say I'm connecting Arduino Uno to sensor, isn't
Yeah,
it? So that
yeah.
means Arduino Uno is controlling the sensors. Many sensors are connected with the Uno. So Uno is the master, and all these sensors which are connected to it are referred as slaves. Okay, this
Okay.
relationship is called as master-slave relationship. This is the first point. So I am able to communicate with you, right, with the help of some language, isn't it?
Yeah.
So similarly, so can you just tell me the communication link which is existing between a master and slave, is it unidirectional or bidirectional?
Unidirectional.
No, not necessarily. It's a bidirectional because Arduino can communicate with sensor and sensor can communicate with Arduino Uno. So that's why it's a bidirectional. Is it clear?
Yeah.
So it's a bidirectional. Arduino Uno can communicate with sensor, and sensor can send its reading to Arduino Uno. So it's a
Yeah.
bidirectional dual channel. So it's a bidirectional communication. So there are multiple protocols. So have you ever imagined how this sensor is able to send a data to microcontroller? Have you ever imagined?
Mm. No.
It is able to send some data, right? This is the temperature. Let's take the example of barometric pressure sensor. So it can send the temperature. I mean, sorry, pressure reading, right? So how is it able to send the data from the sensor to Arduino Uno through wires?
In, yeah.
So here comes the actual movie. There is something called I2C protocol, and there is something called SPI protocol. So there is a separate curriculum for this. We request you, kindly please enroll into that. Our pricings are very low. It's not a promotion. We are trying to bring the technology to as many as students as possible who are looking for it.
Yeah.
So we hope you will onboard with our another course very soon. So as of now, uh, just observe the sensor. So can just what are the pins present on the sensor, header pins?
Yeah. Header pins.
Yeah, what are the different pins over there? Can you just try to read out?
Oh, VCC, ground, SCL, SDA, CSD, SDD, SDO.
Yeah, yeah. So VCC, you know about it, right?
Yeah.
So you know about the ground,
Yeah.
and now after that, what's the thing we have?
What?
After the ground, what's the next pin?
SCL.
SCL, serial. SCL means serial clock. Okay,
Okay.
SCL means serial clock. CL means clock. It's a clock signal. And then
Okay.
next we have SDA, isn't it?
Yes.
SDA means serial data.
Serial data. Okay.
Serial data. SCL means serial clock. SDA means serial data. Okay,
Okay.
so there will be some serial communication. Okay,
Okay.
and the next one SD0, I think so. TSB. So what's the next pin that we have?
Uh, CSB.
Yeah. So CSB means CS refers to chip select. Okay. CS
Okay.
means a chip select.
Okay.
Yeah. So what are the pins we have? Serial clock. We have serial data, and we have chip select, and then last we have SD0. Okay.
Okay.
So now on the new page, on the new tab, search for I2C addresses of BMP280.
What?
I2C addresses, I2C address. Just open the new tab.
Yeah.
Yeah, search for I2C address,
I to
2C
C
space address
address.
space. No, wait a second. Let me complete space of BMP 280. So AI will return some response. So just yeah. Can you just click on show more? So what are the two addresses present over there?
Low and high.
No, not about that.
Zero.
Keep that low
Zero.
and yeah, 0 into 761 and
Five.
another one is 0 into 77.
Yeah.
So for 0 into 76, it is mentioned that if it is in low state. So
Okay.
can just tell me what does low mean over there? What does he referring the low actually?
Means
It is
ground.
given in the parenthesis.
Ground.
Yeah. So which pin needs to be connected to the ground?
No. As sorry. SDO should be connected to ground.
Yeah. If SD0 pin is connected to the ground, then the I2C address will be 0 into 76.
Okay.
Okay. If the SD0 pin is connected to the high means what? VCC.
Which is
Yeah. If SD0 pin is connected to the high VCC, then the I2C address of the BMP280 is
0 into 7.
0 into 77. So we have two different addresses. Okay.
Okay.
So can just search for the full form of I2C.
Uh, can you repeat, please?
In new tab, open a new tab. Try to search for the full form of the I2C.
Okay.
Or else you can search for what is the full form of I2C protocol.
Integrate. Inter-integrated circuit.
Inter
Integrated circuit.
Yeah, inter-integrated circuit. So this is one of the protocol through which data gets transmitted. So let's say you have multiple sensors, right? Let's say you have
Yeah.
multiple sensor with the Arduino. You have a temperature sensor, you have a pressure sensor. So how do you think the microcontroller will be able to differentiate whether the data which is coming, uh, into it is originating from particular, let's say sensor A or sensor B? How will it will be able to distinguish between them?
Uh, means how will the Arduino be?
Let's say you have two sensors. One is temperature sensor and pressure sensor. So both are sending data. Temperature sensor is sending temperature data, and pressure sensor is sending some pressure data.
Yeah.
Okay. So how a microcontroller like Arduino Uno or Nano, how any microcontroller would be able to distinguish whether the data is coming from sensor A or sensor B? It is receiving data
Means
from both the sensors, right? How will it be able to determine whether
in the
the data is originating from sensor A or sensor B?
in the code it is written that this pin is assigned to this sensor, and
Yeah.
in the code,
In the code it is assigned, and moreover there is something called I square C address. So have you ever, whenever you are initializing any sensor, you used to mention that serial dot begin or else something like wire dot begin? Have you ever used that in embedded C?
yes, serial dot begin.
Serial dot begin is different thing for getting output in the serial, I mean in the console port. So there is something called 0 into 76 or 77. You might have used these kind of 0 into those kind of stuff in programming any sensor. Have you ever used, at least have you ever observed?
No.
So okay, this is called as I square C address. Every sensor will have an I square C address. Okay.
Okay.
Inter-integrated circuit address.
Okay.
Okay. So with the help of moreover, every sensor will have a different I square C address. Every sensor will have unique address.
Okay.
Okay. So with the help of this address, now the sensor, Arduino, is able to differentiate whether the data, it already know, like this address is belong to this sensor, this address belongs to this sensor. So with the help of those addresses, it is able to determine whether the data is coming from sensor A or sensor B.
Okay.
So now what do you think the reason could be that the designer, the engineer who designed that BMP280 PCB had put two different I2C addresses? So earlier I told that every PCB will have a unique I2C address. But sometimes few PCBs may have multiple I2C addresses.
Okay.
So now this BMP280 is having how many I2C addresses?
Mm, two.
Yeah,
No.
0
Two.
into 2, 0 into 76 and 0 into 77.
Yeah. Yeah. Okay.
So why do you think the engineer has enabled such an option to switch between I2C addresses?
Mm, so that we can function multiple things on.
So let's say I will tell one thing. So I told that only with the help of I square C address, a master or else a microcontroller is able to differentiate whether the data is coming from sensor A or sensor B, right? So based
Yeah.
on the I square C address, because every sensor usually have different I square C addresses. Temperature sensor will have different I square C address. Pressure sensor have different I square C addresses. So, but let's say you want to connect two BMP280 modules with the same microcontroller. Okay.
Oh,
So, but every BMP module carries the same I square C address. Every temperature sensor will have same I square C address.
no.
Okay. Yeah, actually that's the correct. Unless you are changing the model, company, different company, the same, if it's the same belong to same model, they will have same I square C address only.
Means if I am using two BMP 280 of same company.
Yeah, they will have same I square C address.
Okay.
So now how will this is actually called as I square C conflict error, because both sensors are trying to send data, both are having same I square C address. So how will the Arduino able to manage whether the data is coming from sensor A or sensor B? So it's not possible. So that's why the engineer gave an option. If SD0 pin is connected to ground, I square C address will be 0 into 76. If SD0 pin is connected to high, I square C address would be 0 into 77.
Okay.
Is that fine? So for one
Yeah.
BMP module, you can connect the SD0 pin to low. Okay, so that it will take the I square C address 0 into 76. Okay.
Okay.
So for another module, you can connect SD0 pin to high. So it will take the I square C address 0 into 77. These 0 into 76 and 0 into 77 are reserved for BMP280 modules only. So other
Okay.
than these, if you are taking the same company, other than these two addresses, no other different address it will be having. Okay.
Okay.
So now both are having different addresses. Now both can communicate with the microcontroller. Is that clear?
Yes.
So let's say now I'm having five BMP280s and a single microcontroller.
Yeah.
Now I want five BMP280s to work. How will you be doing that?
I will be connecting the ground to SDOs of all the sensors and
Now
uh,
let's say for one first BMP you connect the SD0 to ground. For the second BMP you connected SD0 to high. So for first one it is 0 into 76 and second one it is 0 into 77. So for the
yeah.
third sensor again if you connect SD0 to ground it will take 0 into 76 which is equal to the first one.
Yeah.
Yeah, but I have now out of five you have managed two. Now we are having three, remaining three. How
Now
will
we
you do
will
that?
assign a different pin.
No matter whether you assign a different pin, I square C conflict error should not be there.
It will only two sensors can work at a time with single
No, you can
microcontroller.
use five sensors also. You can use many sensors.
No idea.
Yeah. So you are done with your engineering.
No, I am in class 11th.
You're in class 11 and you're interested in electronics.
Yeah.
Okay. So have you ever heard the term multiplexer?
Yeah.
Multiplexers and demultiplexers.
Yeah.
Yeah. With the help of multiplexers, we can make as many as sensors to work intact.
Yes.
Yeah. So you know about multiplexers, right? We will connect many things on one side. We have a select line.
Yeah. Means
So,
multiplexers are used to
yeah.
means if you are using many sensors and pins are less, then
Yeah. Right. Right.
multiplexer makes.
Yeah. So that's why we use a multiplexer. Is that clear?
Yeah.
So now can you just tell me, uh, the person who manufactured the IC, the main IC, you can see a small IC that we have also added in the schematic earlier,
Yes.
BMP280 IC.
Yes.
So that is also present in the PCB. You remember? Can you see that?
In the PCB. This.
The PMP280 PCB that we SDs all those pins are there, right?
Uh, yeah. This one. This one.
Yeah. So this is the IC, integrated circuit, main IC. So on the
Yeah.
PCB also that IC is there, isn't it? BMP280 PCB.
Yes.
So the same IC we have added in our schematic also.
Yeah.
So this IC is manufactured by the different company.
But
Actual boss, it is a manufacturing company. So in this course, what we are looking for is not how the sensor is manufactured, or nor we are working on manufacture of PCB. We need to design a PCB with the help of the sensors, which are not manufactured by us. Is that clear?
Yes.
So now we need to design a PCB similar to BMP280, but we will be taking help of this BMP280 IC, which is from Bosch.
Okay.
Is that clear?
Yeah.
So now we need to draw the schematics. See, if you just look into the BMP280 module, just scroll a little bit to the top. I mean, yeah. So you can find copper traces also over there, right?
Yes.
So that means there is a schematic diagram. So now we
Yeah.
need to do that in the schematic page.
Okay.
Yeah. So this is related to the schematics. So this is the assignment that I have given to the all the students in batch 4. They have submitted. They have designed the schematics. There are multiple articles published on this. You can refer to that, and you need to submit the schematics. You need to draw in a schematic page. So now I will show you how to export the schematic page. Okay.
Okay.
Yeah. Come back to ECEDA. So now if you want to export this schematic page into PDF, so your assignment is I have made you to add a IC, integrated circuit,
Yeah.
MP280. I have made you to add few resistors and a capacitor VCC ground. So now I am giving you to make the schematic. Don't go to the layout design or else 3D. I'm not talking about layout or 3D. So you need to make the schematic of it. That's the assignment.
Okay.
Okay. So after this assignment, then we went into the like the for the previous batch. So I started how to place an image in layout design.
Okay.
Okay. So first I will show you how to move to the layout design. So can you stop sharing your screen and come back to Google Meet?
Yeah. I stopped sharing.
Yeah. I'm sharing my screen. So now you are able to see my screen, right?
Yes.
Let me confirm whether the live stream is going on. Yeah, it's going on. So now I'm going back to, so this is the schematic of BMP280. You're able to see my screen?
Yes.
So now can you just read out what is written over here?
SD0 must be grounded to lock I square C ADDR at
Address at the
0 in
0 into 76. So can, this is what we did. Isn't it what written over here? SD0 pin connected to ground with the help of a resistor. Isn't it? SD0 pin is connected to ground. Hello?
Oh, yes, yes.
Yeah, just keep yourself unmuted so
Unmute.
that I can understand. Yeah. Because sometimes there might be network issues, so that's why I need to ask
Okay.
every time. So this is the serial data line. This is the serial clock line. Is that fine? Okay.
Yes.
So through these pins, these are actually I square C pins. I mean I square C lines. Through this data communication will happen with the microcontroller. Okay.
Okay.
So and we have ground. Ground is connected to ground. And here we have ground. Again, this is connected to the ground. You can see over here. And this VDD IO and VDD both are same. Okay. So that's why we have
Okay.
made a short between that. VDD and
Yes.
VDD IO both are equivalent to VCC only. Okay. So now VDD, for VDD we need to give power supply, isn't it?
Yes.
Yeah. So you can directly connect it. You can just take a VCC and you can directly give a power supply. But rather what we did is we added a filter, inductor. You know about filter?
No.
So filters like basically what whenever we give, see by default this is not there in the actual diagram. So we just improvised the circuit diagram. Okay. So we modified the actual schematics of BMP280. So this inductor filters the or else I will tell you one thing. So this capacitor here we have two capacitors, right?
Yes.
These capacitors are called as decoupling capacitors.
Okay.
Okay. So decoupling means whenever any capacitor is placed between VCC and ground, that capacitor is called as decoupling capacitor.
Okay.
Is that clear?
Yes.
Whenever any capacitor is placed between,
VCC and ground.
yeah. So so what is the role of a decoupling capacitor? Any
Mm,
idea? it filters the input power supply. So see, always power supply is not stable, right? Sometimes there might be some fluctuations.
Yes.
So this filters that power supply because IC needs a stable supply.
Okay.
So this is for filtration. Okay, so this is about, and here we have some resistors, right? Over here,
Yeah.
these are called as pull-up resistors. So why pull-up? There are resistors. There is one category is pull-up and another category is pull-down.
Okay.
Okay, so these are pull-up resistors, pull-ups. So why? Uh, if on one side, if they are connected to the data transmission line, these are the data transmission lines. I already told you there is
Yes.
something called I2C protocol. These are the data transmission lines. So if
Yes.
on one side they are connected to data transmission line, and on the another side, if they are connected to the positive, see this is the positive one.
Yes.
So if they are another side, if they are connected to positive, it is pull up. If on another side they are connected to ground, they are called as pull down.
Okay.
Okay. So this is the circuit diagram of BMP280. Okay. Now I will show you how to jump into layout design. So I'm clicking here. So there is a PCB option right here.
Yes.
I'm going to PCB. See, this is the 2D layout. Okay.
Yeah.
2D layout. So here you can see the preview of 2D layout also. If you click on 2D, it will take you. This is the 2D layout design tool. This is the simulation, 2D simulation. If you click here, it will take you to the simulation, 2D. See, this is the
Okay.
2D simulation of BMP280.
You have made it look like it, or when you made the schematic and after that you clicked on layout, it looked like it.
See, directly the schematic is not converted into like this. We need to do this manually. Okay.
Okay.
So that is what pending in our curriculum. Everything is done. We done with schematic, how to place component. Everything is done. Now this is the another part. So we are done with half of the movie in our course. The another half is we are having this kind of schematic. So now how to I will show you. We are having this kind of schematic. How to convert into like this.
Okay.
How to make design this. We need to manually do this. These are the copper tracks. I have shown
Okay.
you. These are the copper tracks.
Oh.
So how to do this? This is the thing. Okay, I'm going to 3D. For now, I will go to 3D model. This is a 3D model. Okay. So now you can
Yes.
orient it in the free space as per your wish. You can orient it.
This
Okay.
is a two layered
This is a two layer because you can find copper
properties
tracks
on
on the
that.
back side. Okay. Now I'm
Yeah.
going to the property. So this is the board material is selected to what? FR4.
FR4.
So now I'm changing the silk screen to colorful silk screen. I told you silk screen can be of two types,
Yes.
standard and colorful. So now I'm just turning it to back. Okay. You can find our logo.
Yeah.
Okay. So this PCB is lead free.
Okay.
So is it better to have lead or eliminate lead?
Eliminate it.
Yeah. So this is the BMP280. So from this one thing you can understand, BMP280 PCBs are manufactured by many people. By importing, for this what we need to do? We need to import BMP280 IC from Bosch,
Okay.
right? So we are also selling BMP280 modules, like these modules. Okay.
Okay.
So if you
So
place
you
an order,
import.
we will send you the BMP280 module also. You can connect it to Arduino Uno and you can test it. It will send it can detect the humidity. I mean, it can detect the pressure and altitude.
Okay.
Is that
Means
fine?
you import this
Yeah, right, right.
IC from
Yeah, yeah,
another country.
yeah. So this is the colorful silk screen layer. Okay.
Okay.
So we can change the color also. Let's say I'm putting it in standard. So this is the thing. I think you have attended this session where I'm explaining you how to change colors. Green is taken as the standard color.
Yeah.
Before that, you
Yes.
missed this much of thing,
Yes.
isn't it? Now, if you directly just join one session and where I'm explaining how to change color, so will you be receiving the entire knowledge or only the partial?
Entire.
Entire. How will you receive only just with one session? How will you receive entire? You will receive partial.
You have covered the syllabus before that, no?
See, I'm telling you, without joining the previous sessions, if you
Oh,
directly join, if
yeah.
you miss the sessions and directly join single session,
Partial, partial.
yeah. So that's the thing. Okay. So always make sure that you attend the sessions properly in time. If you miss a session from this day onwards, again session won't be repeated. If the recording is available, we will post the recording. If the recording may be due to network issue, sometimes recording may be interrupted because it's a YouTube live stream. There is a chance probability for there are many technicalities involved behind that, right? So if the stream is interrupted, if the recording is collapsed, or it's corrupted, so we may not able to provide the recording. So you will lose the concept. We are dealing with so many courses every day, starting from
Yes.
ESP30 to embedded C, where we are having multiple courses. We are Raspberry Pi Zero W, Linux programming, how to design your own operating system. I can build my own operating system also with the
Oh,
help of Linux tools. So we are having these many courses, okay? So it would be very difficult for us to repeat the sessions individually on 1:1 session, because the
yes.
if you just look into the price that you are paying, it's 299,
Yeah.
isn't it? Yeah. So always kindly please join the courses in time. If you miss any session, again content won't be repeated. Okay.
Okay.
Now one more concept is remind. One or two concepts are remind. I will tell those concepts right now. So after that, you will be participating in a quiz. Okay.
Okay.
So after the quiz session, you are up to date with batch 4. You are done with all the 2 weeks are done. In the third week, we are in the layout design.
Okay.
Okay. So now 2 weeks concepts is covered. I think it's been around more than 2 or 3 hours of session we have taken continuously. So we are done
Yeah.
with around 2 weeks is completely done. In the third week, we are little bit pending. So that thing already partially is completed for batch 4. I will cover that. Even after that, still you need to attend from today's session. Okay. Once you are done with the third week, then only 1 week is left. In this 1 week, we will explain you uh, the things like how to export into Gerber file, those kind of stuff. Is that clear?
Okay.
So before that, I will be telling you how to export a schematic page. Okay,
Okay.
how to export schematic page into image or PDF or document, and we'll do some quick quality comparison. So let's say this is the schematic page, right?
Yeah.
Now you want to export it into PDF. There is an export option over here.
Yes.
Click on export. Click on PDF. Okay, you have
Okay.
PDF, PNG, SVG. Click on PDF. Then here in the options, you need to select current page. Okay. And click on export. Directly PDF will be downloaded. See, I'll open that
In
PDF. I'll open that PDF in a new tab. So this is the PDF.
okay.
Okay. This is how you export a schematic page, the circuit diagram. Is that clear? And now just observe
Yes.
the quality. Is this having good quality or not? The
Yeah.
text
Good
is
quality.
also being recognized. It is having good quality. Okay. Is that fine? Now I will export into PNG. PNG file format, basically an image, one of the MIME extensions. So
Okay.
I'm clicking on export and I'm clicking on PNG, image or PNG, and then clicking on export option again. Before that, okay, it should be selected as current page, else it will download a zip file. Export PNG. If it is set to board one, if you are having multiple pages, everything multiple images are generated. They will be stored in a one, I mean
Oh,
encoded
zip.
into a zip format, compressed format. That zip will be downloaded. Since we are having only one page, there is no necessity to select board because only one page schematic, right?
Yeah.
Yeah. Now I exported into PNG image. See, this is the PNG. Now quality, come. Let's compare the quality.
PDF is better.
PDF is better. Now one more format is there, image format, SVG. Now you need to tell is SVG quality is better or PNG is better. Okay. So I'm opening the PNG in. I'm splitting my Chrome window. Okay. This is SVG thing. This is PNG thing. Okay. So I'm just splitting my screen. This is different thing. Yeah. This is SVG. So I will zoom in. So which is having more clarity.
Left one.
left one. So on the left I have PNG or SVG?
Actually,
SVG. So basically, you know XML language?
no.
Okay, fine. If you just press Control U, you will get the code. Okay, that's a
Oh,
different thing. It comes in programming. Okay, no issue. So this is SVG image, this is PNG. Okay, yeah. So we are done with the quality comparison as well. Okay, now let's come back to the main window of where is the tab? Yeah. So now you learned how to export a page, right? Is that clear?
yes, yes,
So here we are having few symbols, right?
yes,
ROHS lead free, made in India,
yeah.
FCC. So ROHS, I already told you about ROHS. You remember that?
Yes, the full
What's
form I
the full
don't remember.
restriction of hazardous substances? Around 10
Yes,
chemicals have been restricted. Among them, polybrominated diphenyls, polybrominated
yes,
diphenyl ethers. FCC means Federal Communications Commission, isn't it?
yes.
So have you ever used ESP32 module? ESP32.
ESP32 I have seen it but not used.
So if you just observe the ESP32 IC, okay,
Yes,
on the
it's very.
ESP32 also FCC symbol is there. I just don't know whether you noticed it or not. I'll show you.
Yeah, I can see.
Uh,
I can see it like that
Yeah,
only.
yeah, yeah, yeah. Okay, fine. So you can see, right, FCCCA.
Yeah.
So it is those are some protocols that the signals are emitting from them do not cause any harm. So they are verified. They do some safety tests. Okay, that is about FCC. ROHS means we should not use restricted chemicals. Okay, is that fine?
Okay.
Yeah. So now you learned how to design a schematic.
Okay.
Okay. Now coming to the layout. So only one topic we have told in layout design, that is how to place an image in layout. So PCB can, if you want to place an image in layout design, it should fall under which category? I mean, which kind of layer?
Uh, can you repeat, please?
If you want to make some image, a logo, just like as we did here, right? I will show you in colorful silk screen.
Yeah.
So if you rotate it back, here you can find our logo, right? Suchana logo.
Yeah.
So can you just tell me this logo falls under which kind of layer?
Silk screen.
Yeah, it's a silk screen layer. All images, text, everything is silk screen,
Yeah.
right? So we only told those batch 4 in layout design how to place an image in silk screen layer. Okay.
Okay.
So just assume, keep these things aside. Right now we are in the keep these things aside. Right now you are in the layout design window. Okay. Don't worry about all this stuff. That will be
Okay.
covered later. How to place an image, that's the thing we need to discuss right now. Okay.
Okay.
So one more instruction is that before placing any image, make sure that the image is in PNG format. Okay.
Okay.
So here one more instruction. So if you want to place a logo, go to visit the website remove.bg. You know why this tool is used for?
What?
Have you ever used this tool remove.bg?
Yeah.
For which purpose have you used?
To remove the background of the
To remove
images.
the background. So if you place a image, so it may having despite the background is white, it is considered still considered as a background, right?
Yeah.
So to remove that background, we use this because if you want to place an image, it should not have any background. So it's a professional standard. Okay.
Yeah.
So click on upload image. You know how to do that, how to remove a background.
Yes.
So this is, as you can see, this is the Suchana logo without background. This is Suchana logo with background, white color background. You can click
Yeah.
that image. You can upload it. It will remove the background. You can download that. Okay. Now it removed the background. You can download that and go back to layout design. So in layout design, now I will tell you how to add that image. Okay.
Okay.
So right now I'm in layout design. Okay, you know how to switch from schematic to layout design. Go to here. So you need to
Yeah.
click on the PCB option. So you'll get this kind of window. So here same option place. How you placed an image in schematic? We went to
Place and
place
image.
and image. Same procedure. We need to go to place. You will find an option image. Click on that. Go to this. Select the image, suitable image. Click on press enter. Okay. Now it will show one more dialog. This dialog do not appear in while you are placing an image in schematic section. But this dialog will pop up when you are placing an image in layout design window.
Yeah,
Okay.
because colorful and
So by default, if you do here you have an option, right? Apply for JLC PCB colorful silk screen manufacturing. So if you place this option, a colorful image will be placed. If you do not place this option, it will be downscaled to a something like a black white. I mean, we call black and white or
yeah.
grayscale image. Okay. So if you
Okay.
want to place a colorful image, click on that. Here you can change the image dimensions as well. So you can provide units in mils or Okay, you can click on confirm. So the image will be placed. Okay, see the image. We have got that image. You can see that.
Yeah.
Now just how we reduced the image, you can modify the width and height as well. Okay.
Yeah.
So here we are having the layer option. Top silk screen, bottom silk screen. So if you place top silk screen, image will be printed on the top surface of the PCB. Okay.
Okay.
If you click on bottom silk screen, image will be printed on the back side of the PCB.
Okay.
Is that fine? So,
Yes.
for the previous one that I've shown you in the 3D visualization, what do you think the layer could be? Is it top silk screen or bottom silk screen?
Bottom silk screen.
Perfect. So now here we can reduce the size also, file size. Okay. But we need to make sure that it is within this uh, area. Okay. And one more thing, you might wonder how we decided this is the board, right? PCB board. So it is having
Yes.
some width, it carries some width and height dimensions, isn't it?
Yes.
So here in the properties section, you can define the width and height. You will be having a width and height option over here, board width and height. So you can modify those width and height as well. Okay.
Okay.
Yeah. So this is up to here we have completed for batch 4. So I hope this session is very informative, isn't it?
Yes.
Yeah. So you felt any boring? I think we covered everything. If you're someone who love chemistry, we taught chemistry. If you one who loves something like a technology, we taught technology. We have shown you some videos, case studies, health effect, environmental related, safety, consumer safety, uh, right? And we told you schematics, how to place an image and different kinds of things. And we told you despite it is not part of the course, I went out and I have told you about I2C addresses. It is not part of the curriculum. So before I wrap up the session in the next 2 or 3 minutes, I will take up the questions from you.
Mm.
You have any questions? You want to ask any
Yeah.
questions?
If like I am placing a motor driver, I want to make a circuit board in which I have to place a motor driver and a microcontroller. For that, I
Okay.
use male header pins.
Yeah.
So, in so how to make that male header pins means
Yeah. Those header
it
pins
will
are
be
also
layout.
available in LCSC. Just search for header pins. You will get header pins. Copy that part number, place it over there. You will get header pins. That's it.
Okay.
Yeah. So will you be enrolling for other course also?
I would not be able to give that much time because I have to go coaching and that's why.
Okay, fine. Okay, at least we advise you to enroll at least for any one of the course so that you can understand much better. And moreover,
If possible, I
there is a certification fee. After a Google form link will be shared tomorrow, or else probably by tonight. Everyone should submit that. Uh, if you want, like this course, like we are offering at lowest price just to support the students who want to learn something new. But if you want a certificate, something like a proof of completion for this course, a minimal fee of rupees 125 will be charged for certificate. Okay. So you need to fill the Google form, and you need to submit your details like name, email, mobile number, address, and you need to attach your profile photo. I mean, a passport size photo. That will be provided whenever we are providing an e-certificate of completion. Your photo will be printed on that. The certificate will be signed by the CEO and founder of Grow IOTA company. Okay.
Oh,
Yeah. So you need a certificate or you want just to complete the course? What you want?
yeah. We'll discuss with my family then.
Yeah, please, I request you just at least have a certificate. At least if you are
Yeah.
unable to enroll for another course, because you need to have something to showcase. If you just say I know
Yes.
this one, that no one will accept. You need to have a certificate, right? So
Yeah.
just pay the minimal fee of 125 for the certificate, and a certificate will be provided after the completion. And again,
Okay.
we have a class within 10 minutes. Join at 7:15.
Okay.
Yeah. So thank you. Bye bye. This is Hemant from Suchana signing off. Bye bye.
Okay.
Yeah, you can leave the session.